Well, now we should be ready to do some of our own reducing of fractions that have x in them. All right, we did some examples in the last video of reducing fractions when there wasn't x, but now that there's x, this might change things. So the first step in reducing a fraction is factoring. Always. Because I can't just do like, oh, 18 divided by 6. Doesn't work. So we have to factor. So let's look, what can we factor from both 12 and 18? Oh, well, they're both divisible by 2, but they're also both divisible by 6. So it's always good to see a biggest factor possible. That means that's the greatest common factor instead of just any old common factor. So when I divide by 6, what's left is 2x plus 3 divided by 6. Now, once it's in factored form, then I can cancel, because this canceling is the same as dividing the top and bottom by 6. So our answer is just 2x plus 3. Now, some of you, and even when I was sort of, talking through it, may have seen that, well, you can just divide by 6 as long as you do it to both. There is a secondary way to do it, where it'd be 12x divided by 6 plus 18 divided by 6. It's like the 6 goes to both pieces. That only works though when there's a single number in the bottom. Like this, there's no way, we can't do that. But in this one, it does work, and you still get 2x plus 3. So I wanted to put that out there, that is a valid way to do this problem as well. So there's two different ways when there's a single number in the bottom. But when there's not just a single number in the bottom, we have to factor. No other way to reduce this. I definitely do not want to just start canceling out x squareds because they match, because you cannot reduce until it's factored. So let's factor. The top is a difference of two squares. So it'd be x minus 2 times x plus 2. And always, even if it's just a mental check, do a quick FOIL, like, oh yeah, I'd get x squared minus 4. The middle would cancel. With the bottom, we're trying to multiply to negative 6 and add to 1 in the middle. That sounds like 2 times 3. How do we add to positive 1? We make the bigger number positive. So we need negative 2 and positive 3. So that's x minus 2 times x plus 3. Now that it's in fully factored form, now we're allowed to cancel. Until that point, we couldn't do it, but the final answer is x plus 2 divided by x plus 3. That is the fully factored form. Now, one thing that we're going to be doing that is a little different is noting what canceled here, because this isn't exactly the same as this original function, because it has this rule that x cannot equal 2. So whatever factored canceled, we got to be careful because we're not allowed to divide by 0. Right? If I plug in 2 into the bottom, let's just try that. So x squared plus x minus 6, and I plug in 2. 2 squared plus 2 minus 6. 4 plus 2 minus 6, that's 0. We cannot divide by 0. So we have this additional rule that it's the same as x plus 2 divided by x plus 3 with this additional rule that x can't equal 2. Because in the original problem, x equals 2 would be divided by 0. And we're going to, be working with that throughout, that when you cancel a factor, that changes the domain. All right, let's try the next one. 4 minus x over x minus 4. Well, clearly we can see that there's, something going on here. But I can't start canceling until we can factor. That's our rule. We gotta factor first. Now, on the surface, there might not be any factor, but I'm not a huge fan of the leading term being negative. So I'm gonna factor out a negative 1 from the top. And what that does is it flips the direction of the subtraction. And again, just multiply. If you want to check that it works, we get negative x and then plus 4. That's exactly what this is. Positive 4, negative x. But now we can reduce this fraction because the factors match. So what we get is negative 1 with the restriction that x cannot equal 4. Because if x equals 4, that would be dividing by 0 in the original equation. Little weird. So one thing that is, good to notice is that anytime you subtract in the opposite order, that'll cancel and make negative 1. Like if I did 10 minus 2 over 2 minus 10, that'd be 8 divided by negative 8. That's negative 1. So it works whether there's x's in there, not x's in there. Anytime you subtract in the opposite order and divide, you'll get negative 1. But we do need this additional restriction on the domain because we can't have the original problem dividing by 0. All right, so that was just a little side example. Next one. Okay, I'm seeing a negative out front. Let me just deal with that. And then I'm seeing subtracting in the opposite order. So that would just be a negative 1. So a negative 1 makes a positive 1. The other way to see that, if you're not, a huge fan of what just happened, is that negative out front is like multiplying the top by negative 1. Right, that's really what that is, right? When I see a negative out in front of a fraction, I put it with the top. It does need to be distributed to both pieces. And so I'd get negative 3, and then a negative times a negative makes a plus x over x minus 3. Now this is the same thing. It's in a different order, but the top still is x minus 3, just in the opposite order. And anytime you divide a number divided by itself, that equals 1. But it equals 1 with this additional restriction that x cannot equal 3, because that would make the original problem divide by 0. So anytime we cancel a factor, that changes the domain. A little strange, I know, but it's going to take practice, but hopefully we can get through it. Let's do some multiplying. All right, so to multiply rational numbers, first, factor. It's all about factoring when we multiply and divide. All right, so they give an example of, basically what we were doing in the last video, so I'm not gonna necessarily go over it, but let's do it when there's x's in there, because that's what's more interesting. We need to factor all 4 numerators / denominators. All of them need to be factored. So let's start with the first numerator. The GCF is 5. It's not like a difference of 2 squares, it just has a common factor of 5, and then what's left is 2x plus 3. All right, let's do the bottom. Looks like the common factor is 10, and then what's left is x minus 5. All right, and again, multiply out if we're not sure. All right, numerator of the second fraction is difference of 2 squares. So that's x minus 5 times x plus 5. Because it's 2 terms with a squared, there's no GCF. The denominator of the second fraction has a greatest common factor of 3, and then what's left is 2x plus 3. So I factored everything, and I wasn't worried about what's matching, what's not. I just needed to factor correctly. Now let's look for what's matching. I see 2x plus 3, those cancel. One's on top, one's on the bottom, so we can divide both top and bottom by that and get rid of it. And then x minus 5, x minus 5, x minus 5 is a common factor. So yeah, let's just go with that. So now what's left on the top is 5 and x plus 5. I do not want to multiply out, especially denominators. But I do need to know that 10 times 3 is 30. And that's all that's left in the bottom. The reason I was hesitating earlier is because 5 over 30 also reduces. That's sort of back to our original view of what it means to reduce, is to divide the top and bottom by the same number. I'm not dividing the x plus 5 though, it's its own factor, but I need to reduce 5 over 30 into 1 over 6. So it's 1 times x plus 5 over 6, or just x plus 5 over 6. So that is the answer. Let me make my 5 look a little better, except we got those restricted domains. So we need to set each factor that canceled that's no longer in our answer equal to 0 to find domain restrictions. So we have 2 of those in this problem. We have 2x plus 3 equals 0, and then x minus 5 equals 0. X minus 5 equals 0, that's not too bad. You just add 5 to both sides. So x equals 5 is our domain restriction. So right away we know x cannot equal 5, because that would have made the original problem have a 0 in the denominator. That's the idea. All right, let's do this one. We have to subtract 3 from both sides. 2x equals negative 3, divide by 2, divide by 2. So x is negative 3 over 2. Don't freak out that it's a fraction. Negative 3 over 2 is a lovely number. If you really would rather, you can write it as negative 1.5. But nothing wrong with just leaving it as a fraction. So that's our answer, is that this whole thing multiplied to x plus 5 divided by 6 with the added restrictions that x can't be 5 or negative 3 over 2, because those two numbers would make the original problem divide by 0.